right, today we're going to start a little thing called matrices. We're going to have a little introduction to what they are. Basically, matrices is a way of organizing data. Okay? And so right now, I want you to think of this right here as a whole bunch of numbers that are being organized into two things: rows and columns. Now, a row is considered to be the horizontal part of the matrix. All right? So we come in here. How many rows do you see? 3. So right here, what I'd like you to do right here for problem number 3, I'd like you to label it as 3 rows. Columns. By the way, what do you think of columns? Does anybody think of anything in history that has columns? The Ionic, the Doric, the Corinthian. All right. When you guys go to visit Europe someday, you will start seeing beautiful columns.
Buildings in Washington.
There you go, Washington, D.C. You see the columns. You go to the Lincoln Memorial. Beautiful columns. All right. So columns run vertically. So how many columns do we have? 4. So we have 4 columns. So, by the way, if somebody said, what are the dimensions of this matrix? The dimensions are simply a 3 by 4. That would be your answer for number 3. It asks you for the dimensions of that particular matrix. They always start with the rows, then the columns. Okay, so you count the number of rows, then you count the number of columns. So why don't you guys go ahead and do the first 2 on your paper, and we'll move on to the next part. All right, so let's look at the first couple here. I'm going to scroll right over here. I have this matrix. Andrew, how many rows do you see? 1. How many columns do you see? 3. This matrix would be a 1 by 3, and that's all I'm asking you to do for problem number 1. All right, you ready now? Okay, sliding over to number 2. How many rows do you see? 2, correct. 1, 2. 2 by how many columns? 3, that's it. So 1, 2, and 3 just simply asks you how many rows and how many columns. That's it. Now, interestingly, let's look at number 8 right here. Number 8 is referred to just by itself. This is considered to be an element within the matrix. Now, this element is in a particular location in the matrix. If I said, locate me number 8, well, actually I have 2 number 8s, so that's not a bad idea. But this particular number 8 is in what location? What row am I in? The first row. Second column. Very good. All right. So column 2. So you could say it's in row 1, column 2. Row 1, column 2. You could locate things. All right. So it's a way of, remember, matrices are a way of organizing data. So let's go over back to our very first one. So right now we know what a matrix is. It's a way of organizing information. We have an element. We have to mention what in the world is a row matrix. A row matrix is where you have 1 row. Yeah, like number 1. That's a row matrix. So 1, 2, 3. If I have 1, 2, 3 right there, this is a 1 row by 3 columns, but this is considered to be a what? This is an example of a row matrix. So you put this in your journal right here. Put this in your journal. That's an example of a row matrix.
Does it have to be order?
Well, no, I could do 2, 1, 3, and that's still considered to be a row matrix. Just 1 row. Okay? Good question. Just an example of a matrix that's in 1 row. You can put any numbers you want. You could put, if you wanted to, you could say A, B, and C. That's all. These are all examples of just a. If you're only doing 3 numbers, what if I did 1, 2, 3, 4? That's still a row matrix. All right. All right. Next thing I want us to talk about is a column. What do you think a column matrix is? Just 1 column. That's right. So a column matrix, everybody. If you wanted to know what a column matrix is, just make 1 long column. All right? You can write 1, 2, 3, just to make things funny. 5. The certain thing is it doesn't have to be in order. Okay? Even though I take it down. So a column matrix is just one column. A row matrix is one row. I wonder what a square matrix is.
Square.
Okay. 2 by 2. 1 by. Very good. So let's do that. Right here in your journal, write square matrix. I'm going to make a 1 by 1. I'm going to make a 2 by 2. I'm going to make 3 by 3. So a square matrix is any matrix that's in the form of a square. This is a 1 by 1. That's a 2 by 2. That's a 3 by 3. You'll be working with 2 by 2s and 3 by 3s a lot when you're working with matrices. Okay? Zero matrix. Zero matrix is very, very, very easy to remember. It's a matrix that just has a whole bunch of zeros. Okay? So you can make any matrix that you want. If you see a matrix that's a 2 row by 3 column, this is a 2 by 3, but all you see is a whole bunch of nothing. That's referred to as a zero matrix. So there's not just one zero matrix, there's an infinite number of zero matrices. Okay? But it has all elements, all the elements. By the way, that's an element, right? All the elements are 0. Okay? Now the last thing we're going to do is we're going to talk about this thing called what? Equal matrices. So could you guys put number 4 in your journal? Let's look at number 4. Number 4 is a 1 by 2, which is equal to this 1 by 2. It's 1 row and 2 columns. This is where it gets a little bit trickier. You got to understand that each element in this matrix has to equal each element in that matrix. And I'm highlighting it color so you can kind of hopefully see what I'm saying. This element has to equal this element. So you're allowed to say 4x will definitely equal 24. And 42 will definitely equal 6y. So when it says solve each equation, you have to take each element and set it equal to the other element. I see a whole bunch of light bulbs going on.
So y be 7 because 6 times
That's right.
and x would be 6.
That's right. Good. Perfect. X equals 6 and y equals 7. So for your answer, simply put x equals 6 and y equals 7. All right, we're going to go down to number 10. It's a little bit more challenging. All right, here we go. I have to zoom out just a tad. There we go. So here's number 10. What I'm going to do is I'm going to highlight each element in its own color. So right here, hopefully you can see that negative 5 is totally equal to a negative 5. 3x plus 1 is going to equal x minus 1. 2x minus 1 is going to equal, sorry, not 2x, 2y minus 1 is going to equal 3y. And finally, 3z minus 2 will equal 5z minus 4. Which means, remember, I'm saying this matrix is equal to this matrix. By the way, what are the dimensions of this matrix right? What are the dimensions? It's 2 rows by 2 columns. And this is 2 rows by 2 columns. Okay? So obviously we don't have to solve for anything here, do we? Because negative 5 is equal to a negative 5. In red, what I'd like you to do is I'm going to write 3x plus 1 equals x minus 1. In green, I'm going to put 2y minus 1 is equal to 3y. And in magenta, I'm going to put 3z minus 2 equals 5z minus 4. There we have our 3 equations set up. In the first equation, what are we solving for? We're solving for x. In the second equation, we're solving for y. And in the last equation, we're solving for z. So once again, now we've kind of broken it down into 3 different equations. They're not difficult. Whenever you're solving for x, what do you want to do? You want to isolate all the x's to what? One side of the equal sign. Where do I have the most x's? The left or the right? The left. If I have all of my x's on the left, then I want to move all of my x's to the left. So I'm going to take away an x here. And I'm going to take away an x here. And now I'm left with simply 2 x's. If I move all of my variables to the left side of the equal sign, it means I need to move all my numbers to the right side of the equal sign. So how do I get rid of a plus 1? Minus 1. Minus 1. Does everybody see how this zeroes out and this zeroes out, and a negative 1 and a negative 1 combine to make a negative 2? And at this point, you just have to divide both sides by 2. And x is equal to negative 1, and we just solved for x. Now, let's go over here to our solving for y. Whenever I'm solving an equation, the first question I ask is, where do I have the most positive y values? Where is my greatest number of y's? I would say my right side has the greatest number of y's, which means I need to take this guy and get rid of it. How do you get rid of a 2y? Subtract 2y here. Subtract 2y here. And I get negative 1 is equal to 1y. Which means y is equal to negative 1, and I'm done. Okay, we're down to our last one. Solving for z. Where do I have the most positive z's? On the left side or the right side? The right side. This is where I have my most positive z's. There's 5 of them. So if there's 5 z's over here, and there's 3 z's over here, how do I get rid of a 3z? That's right. Take away 3z from this side, and take away 3z from this side. See what I have left, right? I have a negative 2 equals 2 times z minus a 4. But I got to get all of my z's by themselves. I've got to isolate it. So what I have to do to get rid of this negative 4? Plus 4. And plus 4. You guys notice how every single time these are what? Always opposites of each other, right?
Mm-hmm.
That's the number one mistake when students are doing it. They don't do opposites. Okay? So this zeroes out. Plus 4 and a minus 2 is just simply a 2. 2 equals 2 times the number that we're looking for. And yes, the number that we're looking for is simply a 1. So x was equal to negative 1. Y was equal to negative 1. Z was equal to a positive 1. These are your 3 answers for number 10. Now the next video we'll do one that's a little bit more difficult than this one. All right, but what did I do first? I isolated all of the elements that made them equal to each other. So I knew which element I was solving.